Hello everyone, today let's solve insertion sort list. So given us sort list, we have used insertion sort to sort it. So let's see how we can approach this. So in here, I will use the original list as a source of input. Each time we will take the node and compare with the sorted list. So it means that I will create another list which is sorted and initially is empty. And we will use another pointer that's always point to, in the beginning, always point to the head of the sorted list. So let's sort it. So 29, the source of input in the beginning is 29. 29 compared to the current sorted list, right? So it's nil. Whenever we encounter nil, so it means that we have to put it up front. So how can we achieve this? We will use this logic. So given node next will point to the current, okay, and then we just return node. So it means that the given node will become the new head of our sorted list. So it will become something like this. So the given node will become the head of our sorted list, and it points to the previous head. So the first iteration, we finish this, and then the second iteration, 23, right? 23 is smaller than 29, means that you have to put up front, so we still have to use this logic. Right? So 23 has points to the current node, and we return 23, and 23 will become a new head of our sorted list, which is like this. Okay, and then the third round is a little bit different, since 82 is bigger than 23. Okay, so we will use follow this logic. As long as next node is not nil. Okay, next node is not nil. We have to use the next node to compare with the given node. Okay, and if the given node is bigger than the next node, we have to keep moving our current node in order to find out a position that is suitable for our 82. So in this example, 29 is smaller than 82. So we move current here. And since current next is nil, it means that we no longer satisfy this condition. So we have to put 82 in the middle, in here. Okay? We have to put 82 in here. So how can we achieve this? So we have to use this logic. Node next means this node, 82, next has to point to the current next. So the current next is nil. So it means that after this algorithm, okay, this assignment, 82 will point to nil. And then current next point to the nil, means 29 will point to 82, which become like this. And then we finish the third iteration. And the fourth iteration is the same, since 11 is smaller than the head of our sorted list. We just put 11 to the front, right? So using this logic. So 11 next has points to the current, and return the 11 as our new sorted list. So it becomes like this. Okay. So let's implement this in code. So maybe you will have a better understanding. Okay. So here. So in the beginning, we have to check the boundary condition. So if head is nil, we just return the head. In here, since we have to create a sorted list, right? We create another list. So I just call it sorted. And this is this node, pointer to this node. And I also has another pointer that points to this original head. Okay, the source of input. And we will use a for loop here because each time we have to give an input and compare with the sorted list. So whenever our current is not new, it means that we still have something new to compare. And we have to remember the next node first, because next node has to compare to the sorted list. Okay, so we have to remember it. Current next. Then in here we have to compare. So I will create another function called sorted list, and we will put the head of our sorted list and the current node. Okay, the current node is 29, and then after the iteration, I will assign 10, which means the next node as the current node. So in the next iteration, we were able to use the next node to compare with the sorted list. In the end, we just return sorted. Sorted is always the head, okay, of the sorted list. So here we just need to create a sorted list, and input is here, head, and the node, the given node. It's also a linked list. It's a list node, and we have to return the header of the list node. So in the beginning, right, if node is the given node is nil, the boundary condition, we just return the head of a link, the sorted list. And here we have to use the logic, right? So if head is nil, or the head or the node value, okay, is smaller than our head value, means that we have to put the given node to the front. So we have to use this logic. So node next will become the head, or maybe I can let me assign, okay, change the name, because we don't want to lose track of the head. So I assign head to another variable called current. Okay. So the node next will become current, and we just need to return the node, okay, because the node will become our new head. Okay. And then if we don't satisfy this condition, current is not nil, and the current value is bigger than the given node, it means that the given node is bigger, right? Bigger than our current node. So we have to do the following. So as long as current next is not nil, okay, and the current value is smaller than the given node, we have to keep moving the current node in order to find out the position for the given node. Okay. And after iteration means that we find out the position. So we just follow this logic. So node next will point to the current node next, and current next will point to the node. And in the end, we just need to return the head. And let me check. Yeah. And that's it. So the time complexity for this algorithm is n squared, because each time we have to loop through the sorted list. Right? Whenever there's a new input, new given node. We have to work through all the sorted list. So it's n squared, and the space complexity is O1. It's OM since we use an extra space to store the sorted list. And submit it. Okay, let's see what's the problem here. Oh, we have to compare the current next value instead of current value. Yeah, and that's it. Thank you for watching.